It seems a lot of you have compared this channel to the likes of what Strider7X has published with the original Paper Mario game, which I suppose makes sense given that we're both channels specializing in making videos on a single game. As a fellow fan of his content, I really enjoyed his videos focused on creating soft-locked or non-progressible save files in Paper Mario. So, after finding some similar ways to achieve this in Animal Crossing, today I thought we'd have a little fun and create an impossible save file ourselves by intentionally glitching out the game. So, let's dive in. Let's start with some definitions. First, when I say we're creating an impossible save, I really mean we're creating an impossible to progress save. Admittedly, my teaser might have been a bit misleading, but we are not trying to corrupt the game's save data or make it so you can't even boot the game at all. That is, the goal of this video is to intentionally set up the game in a way that soft locks normal game progress. But this is a bit difficult to properly define in Animal Crossing, since its gameplay does not exactly follow linear progression. Nevertheless, there are still things you're theoretically supposed to do in Animal Crossing, like pay off your debts, upgrade your house, collect bugs and fish, and so on. So for the sake of this video, I'll consider tasks like those as progressing the game. So now the question is, how do we prevent the player from doing any of these tasks? An easy way to do this outside of the confines of the game is to just edit your save file manually and place corrupted acre chunks around your player house. I mean, technically, if you can't really move out of your initial starting position, then you can't really progress the game. But this is of course accomplished using external tools, and while fun to play with, is not much of a challenge. Using just what's available in-game, it turns out you can softlock yourself indoors by having a full inventory and setting up furniture in specific ways. You can also do a similar thing outside with signboards. But this is easily circumvented by just resetting the game. So, is there anything interesting left to create a truly impossible to progress save file? Well, the answer turns out to be related to a teaser from my previous video, so we're again going to be looking at Tom Nook's secret codes to set up some glitchy scenarios. On the topic of this previous video, a few of you, myself included, were a bit disappointed that I didn't explain the encryption process Nook codes use to their full extent. And it turns out actually diving deeper into explaining these provides some interesting context for how Nook code glitches work for this video. So I'd like to take this opportunity to explain these now. To quickly recap, in this game, you can tell Tom Nook a secret password code anytime his store is open to get special items. So if you want a certain item in the game and that item is able to be generated, you can use Cuyler's program to get a valid code for said item. Anyways, regardless of what code type you choose to generate, the process for encrypting these codes is similar, still utilizing a combination of bit shifts, shuffles, and reversals, as well as transposition, substitution, and RSA ciphers. To make good on my promise and get a bit more technical, let's talk about each of these. First, bit shifting typically involves both left shifts and arithmetic right shifts. For example, if we start with the binary number 0010 and perform a single left shift, the bits of course shift left once, leaving us with 0100. During arithmetic right shifts, on the other hand, the most significant bit is copied over and the least significant bit is lost. So, in a big Indian environment, this means that the leftmost bit is copied over to the new number while everything else is shifted over to the right. Bit shuffling works in the same vein, but of course instead of shifting left or right, we are instead shuffling the order of bits around to get a new number. And from this, you can probably guess how bit reversing works as well, where the new number is just the order of bits in the original number, but reversed. So perhaps more interesting and complex are the ciphers that the game uses to further encrypt these Nook code passwords. A transposition cipher simply takes letters and moves their order around, using a keyword as a reference of the new position. This is most commonly used by taking the alphabetical ordinal values of the keyword to encrypt the plaintext into a ciphertext. As a fun fact in the last video, I mentioned that the developers actually used real staff member names as a reference for this transposition step. So for example, let's take the keyword hunter in a transposition matrix and rank these characters based on their alphabetical ordinal appearance. Doing this, we get the letter E as 1 since it appears first out of all of these letters, H as 2 since it appears second, N as 3 as it appears third, and so on. If we then have a plaintext password, Animal Crossing, we can write this down tabularly in this matrix and read it off in column order. So, reading down the first column, we get AS, then the second column, we get ACN, the third column, IO, and so on. So the plaintext Animal Crossing would eventually become this ciphertext as a result. Now, admittedly, the way Animal Crossing actually handles this is a bit different, but the idea is the same, and this is the easiest way I can explain it. Next, substitution ciphers are a bit more simplistic and work by just mapping certain characters to other, different characters. This is probably what most people think when they hear the word cipher, where the letter A, for example, could be mapped to the number 7. A message is then encoded and decoded by just simply following a substitution key, which I actually remember being a pretty popular puzzle on the back of like restaurant kids menus. Anyways, the last cipher to talk about is the RSA encryption, which is the big boy. RSA stands for Rivest Shamir Adelman, who are mathematician geniuses, and this algorithm they came up with famously uses some fairly complex math. This typically involves prime numbers and Euler's totient function. Now, to try to explain this mathematically, you start with two prime numbers which are then multiplied together to get a new number called n. N is then ran through Euler's totient function, which spits out the total possible numbers that are co-prime with n, called c. A new number is then chosen that is between 1 and c, and also co-prime with both n and c itself. This number, along with n itself, make up the public key of this RSA encryption. Our message can then be encrypted by converting our message numerically, raising it to the power of the first key number, and doing modular arithmetic with the second key number. We can then convert this number back into letters and get an encrypted message. Now, decrypting this message back to its original is a whole nother can of worms. This involves a new private key, which is derived from setting the first public key number multiplied by a private key d, taking mod c of this value and setting it equal to 1. You can then solve for d to end up with a decryption key composed of d itself and the original n. Now, if through some miracle you are able to follow along with my math, then you might have noticed that there are a bunch of values that d can actually be. And generally, you want to pick higher values, since the higher d is, the more secure your encryption becomes. Anyways, needless to say, this is a pretty complex system, and the strength of RSA encryption comes from choosing large prime numbers that are difficult to decrypt. But it turns out Animal Crossing actually screwed up this code quite a bit, and their original prime numbers will always be two unique primes between 17 and 29 inclusive, or a possible range of 4 values, which is pretty funny. Whew, that was a lot. Anyways, when all is said and done, the Nook codes go through a checksum to ensure it is a valid password. However, like I explained last time, this checksum is just 2 bits long, allowing for a ridiculous amount of invalid passwords to actually be flagged as valid. And to finally get back on topic, this checksum oversight is what we're going to abuse to create an impossible save. Through understanding how Nook code encryption and decryption works like this, we can actually find invalid codes that point to items outside of the valid range that Nook is supposed to be able to give to us. Now, this would typically cause a checksum error, but again, since this checksum is only a minuscule 2 bits long, we can abuse this to generate specific codes that both give us invalid items and pass this checksum. In this case, using this code will cause Nook to hand us a permanently unopenable present in our inventory. You cannot drop, open, or otherwise do really anything with this present, and clicking it simply plays the error noise over and over. So if you end up saving, this effectively means we have, under normal conditions, destroyed a slot in our inventory forever. And you can probably see where I'm going with this. That is, to create our impossible save file, we can just start a new game, complete the opening chores, fill our house with some items and pattern clothes, and use this glitch Nook code to fill our inventory with unopenable presents. This will effectively remove all of our inventory space, meaning we can never properly pick up or buy anything ever again. And because we filled our house beforehand, we can't even enter our house properly. Without such a crucial mechanic like the inventory available to us, we are basically soft-locked from ever progressing normally. We can never use any tools, catch any bugs, upgrade our house, or earn any bells. Sure, you can walk around your town in your current state and talk to your villagers, but this town is now permanently set like this with no further customization options or progression available. Now, you may be thinking that villagers could potentially offer to buy one of these glitch presents from your inventory, and thus free up a spot. But to my knowledge, no villager will ever attempt to buy one of these present items. But some of you well versed in the original Animal Crossing may also know that visiting another player's town and resetting on the train will remove all of your items in your inventory. This will also give you this cool gyroid face, but that's besides the point. Anyways, if you then endure resetting and save and quit, you can have all of these glitch presents removed from your inventory and your town is effectively fixed. The problem is that this requires a second memory card, but it's true that this method makes our impossible town not quite so impossible. So let's get even more creative. My solution to this workaround is to use our old friend, the beta paper airplane. Of course, some of you may think this is cheating since the beta paper airplane can only show up in your town under such ridiculous conditions that it's practically an impossible chance in and of itself, which is very fair. But honestly, I couldn't think of another way to circumvent the train station reset, okay? I originally wanted to place signboards in front of the train station, permanently blocking your path to it. But you actually cannot place signboards on this cobblestone path. So, my workaround will still involve this paper airplane. I already have a video on this beta paper airplane, but to cause this item to show up in your town, an extremely rare hardware failure would need to cause a bit flip to occur when calling your town's empty grass acres. If you are lucky enough to get this item in your town, an error in the game's actor code actually causes this plane to duplicate itself upon reloading your town map. I neglected to mention this in my original video, but the plane only duplicates to empty adjacent plots. This means you can drop items around the paper airplane and actually manipulate the direction it will duplicate towards. So, through careful planning and a lot of map reloading, you can theoretically set up these planes in a way to be sitting on the train station acre. And now, reloading the overworld over and over will cause these planes to spread to empty plots on that acre. You can then save the game in this state, and then attempting to enter the train station acre will end up crashing your game as it tries to call in all the planes. This way, we can go to Nook's and fill our inventory with glitch presents again, but now we have no way to go to the train station and remove these items from our inventory. So now, our town is truly impossible to progress. It is impossible, right? Well, typically it would be, but during editing this video, I found another way to fix your town and make it progressible again. I actually think this would be a fun challenge to see if any fans of the original Animal Crossing can actually figure out the solution on how to fix this impossible town themselves. We can admittedly truly make this save impossible by just using the paper airplane trick to softlock ourselves inside the player house acre, but assuming we did not do that or use the train station reset trick, how do you go about fixing your inventory? I have a particular solution in mind, but I'm wondering if someone else is able to figure this out as well. Feel free to comment with your guesses, and I'll actually pin the first comment that figures this out correctly. If nobody gets it by the end of this video's original posting weekend, then I'll just post the answer myself. If you're watching this in the future, check the pinned comment for the answer. Anyways, if you don't use some obscure workaround, this method becomes as close to an impossible save as we're probably going to get. Hopefully you enjoyed this fun little challenge video and the expanded explanations on Nook codes. While I may have a degree in computer science, I'm admittedly not the best teacher. So, if you want further explanations on the ciphers and bitmath, I recommend checking out Eddie Wu's channel, who is a far better teacher on this stuff than I am. As always, special thanks to Cuyler for assisting with information in this video. And also, special thank you to my Patreon and YouTube members, including Lunascape, Inferno Wrath, Raccoon, Cynthia, Tyrant Link, Cowarun, and Dylan Trudeau. And finally, thank you all for watching. Until next time.